Hi everyone, I'm Lorraine, and my presentation is on the effect of hand size and interaction modality on the virtual hand illusion. So one question in virtual reality is how subtle changes of the body may affect perception. Lanier and colleagues pioneered some of the first informal virtual environment studies in the 1980s. They found out that people quickly learned to adapt to new and unusual bodies. One of their most curious experiments involved attaching an extra virtual set of arms under their current arms, like a lobster. And they found that people quickly learned to use their knees and their elbows for movement. Inspired by examples like this, we're interested in knowing, with a change of relative hand size, what differences will people experience when they do virtual tasks? We're also interested in looking at how using gloves versus game controllers influences this, and how these factors also influence efficiency and fun. The feeling that a body or a body part belongs to oneself has been termed the body ownership illusion. Subsequently, feeling that a rubber or otherwise fake hand belongs to oneself is termed the rubber hand illusion. The rubber hand illusion was first demonstrated by Botvinnik and Cohen in 1998. For this illusion to occur, a participant is asked to place their own hand behind a barrier so they can't see it. A fake hand is placed in front of them where they can't see it. Touching the fake hand and the real hand at the same time lets the participant feel like they own the fake hand because that's what they're seeing. Witkoff et al. Conducted a study on the rubber hand illusion with differing hand sizes. They asked participants to perform synchronized finger movements with a reflection of their left arm that was either normal-sized, magnified, or minified. They found that participants felt like they owned the normal hand the most strongly, but that ownership did increase for the other sized hands after the finger moving task. How is perception of hand size influenced when objects are introduced? Gibson originally introduced the influence of perceivers' bodies on perception. He stressed that individuals don't perceive the environment, but rather the relationship between their body and the environment. This reasoning gave rise to the body-based scaling hypothesis, which says that the body is the metric for defining object size. So participants given a large hand would underestimate object sizes, and participants given a small hand would overestimate object sizes. Agoa et al. Found that people generally perceive virtual hands as larger and virtual objects as smaller. But when interacting with objects, they tend to perceive the overall size of both depending on if they see the object or their hands first. We also look at previous work on interaction modality for our study. Gesture-based interactions may create a more natural experience, but they're also frequently associated with diminished performance. Moering and Froelich compared finger-based and controller-based raycasting in a cave and HMD. They found that users preferred finger-based interaction, but that controllers offered better performance. They also found that performance could be improved by adding visual and tactile feedback to the finger-based interactions. Porter et al. Explored users' behavior in a VR game that implemented both direct motion-based controls and indirect button-based controls. They found that while users enjoyed the motion-based controls more, they often used motion controls and buttons frequently side by side. This leads to our research question. We want to know how different hand representations affect the virtual hand illusion. Since the interaction modality might play a role when answering this question, we also take that into account. Our study uses a 2x3 design, and we recruited 20 participants. Our independent variables are the hand maul size and the interaction modality. For maul size, we observed how participants perceive hand mauls if the mauls are the same size as their hands, 25% smaller than, or 25% larger than their hands. We also look at interaction modality. This is whether participants directly controlled their hand mauls with motion capture gloves or with Oculus touch controllers. Our hypothesis is that the virtual hand illusion will be stronger for participants in the glove condition, and it will be stronger for participants with the fit hand condition. Our main dependent variable is the strength of the virtual hand illusion or ownership, but we're also interested in how participants feel about agency, realism, immersion, efficiency, likability, fun, and the perceived size of their hands. Our participants stand in the middle of a motion capture system, a small table. They view the virtual environment through an Oculus Rift head-mount display. Hand tracking information was provided with motion capture gloves matching participants' hand sizes. This is an overview of our study procedure. The participants began with an introduction and demographic questionnaire. In VR, the avatar is calibrated to fit the body in the experiment, and participants complete each of the 12 puzzles using either the glove or controller interface and with either small, fit, or large-sized hands. At the end, we also obtain qualitative feedback of the post-study interview. After the demographic questionnaire, the participants put on the motion capture gloves, and this is what they see in the motion capture system. They'll be seeing from the first-person view of the robot, which is why the head is obscured, so it won't block their vision. And in this first scene in a fitting room, we have them make a T-pose to track and scale the avatar's arm length to theirs, and then we have them put their arms in their lap so we can adjust the torso to their height. Next, they see the main puzzle scene. The participants are asked to take as much time as needed to become comfortable with the virtual environment. It's a small room with a table and a box, and they play through a tutorial stage first with 3 simple puzzles and a background image with instructions as seen on the left. In the tutorial, participants learn how to use their hands to move blocks, stack blocks, and assemble structures. Every time a new puzzle is completed, another one comes up from the ground. Once the tutorial stage is complete, participants are asked if they're ready for the main puzzle scene. We had 12 main puzzles in our study, and the number of blocks ranges from 7 to 13 per puzzle. Here's a video of some of the gameplay of our puzzles in the controller condition. To measure our dependent variables, we gave a questionnaire after every condition. Based on previous virtual hand illusion questionnaires, we asked participants to rate statements testing ownership and implications or signs of ownership, as well as our own questions. Participants chose a rating on a 7-point Likert scale ranging from 1 for strongly disagree to 7 for strongly agree for the statements, except for the hand size question in which participants reported their virtual hand size from 0 to 200% of their real one. Here's a video of our questionnaire as well. We also collected play data. This is the time the participants took on each puzzle, the number of items they grabbed, and the number of items they dropped, not including successful placements of puzzle pieces. We analyzed all the questions we asked, and we can confirm our first hypothesis that the virtual hand illusion is stronger for participants in the glove condition. Here's our graph for the 3 ownership statements averaged. The y-axis is the participant's rating, and the x-axis is the hand size condition. Answers for the glove condition are blue, and for the controller condition are green. The error bars represent the standard errors of the mean in all the graphs. When analyzing the 3 ownership statements together, we found a significant main effect of modality where the glove condition generates a higher level of ownership than the controller condition. We saw significant effects for statements beyond ownership as well. For realism, we found a significant main effect of modality where participants felt the hands on screen were more realistic in the glove condition than the controller condition. For the efficiency statement, we found a significant main effect of modality where participants felt like using the controllers was more efficient than using the gloves. In likability, we found a significant main effect of hand size where participants liked the fit hand more than the large hand. For perceived size, we asked, what size were your virtual hands? The participants were able to differentiate between all of the hand models. On this chart, the y-axis shows the participants' estimation of their hand size in virtual reality. The x-axis, again, is the hand size condition. The glove rating is in blue, the controller rating is in green, and the actual size of the virtual hand model is in black. Like Ogawa et al., we found that participants overestimate the size of their hands in virtual reality. and participants rated hands in the controller condition as larger than in the glove condition. Analyzing the play data, we found that participants spent less time in the controller condition. They also grabbed and dropped objects less in the controller condition. This supports the participant ratings of the controller condition being more efficient. In conclusion, there were multiple main effects of modality. We confirm our hypothesis that gloves induce a significantly stronger level of ownership than the controllers. Gloves also increase perceived realism, though we didn't change our robot model throughout the study. This could be attributed to the fact that they were able to move individual fingers in that condition, and it was a more natural-looking hand motion as a result. We found a significant effect of modality where participants more accurately estimated perceived hand size in the glove condition. Several participants were observed playing with the finger movements throughout the study in the glove condition, and maybe being able to control their fingers had them feeling more self-conscious and thus better at judging their hand sizes. Our play data supported participants' perceived efficiency for the controller condition over the glove condition. One reason for this might be in the tracking and grasp detection. Our motion capture system was well calibrated, and our thresholds for grasp detection were carefully adjusted, but it was still less reliable than a button press. I do want to note that in our post-study interview, 13 of our 20 participants did say they still preferred the glove condition, despite the controller condition resulting in better performance. Although there were no differences for agency among our conditions, we found that participants generally had high ratings for feeling like they could control the hands. Being able to move the hands alone may have been enough to generate high agency among all our models, but grasping was also our only task, and since we assigned buttons to the controllers to mimic a grasp, that may have been convincing enough to place them on a similar agency level with the gloves. In contrast to Witkoff et al.'s findings, we could not confirm our hypothesis that having a hand size similar to one's own induces a stronger virtual hand illusion. Participants, however, did rate liking hands that fit them over larger hands. In summary, the choice of interaction modality should depend on the application. If realism and the intensity of the virtual hand illusion are important, we recommend using gloves. If task efficiency is the main focus, controllers should be used. An accurate hand size can be used to increase how much users like the appearance of their virtual hands. There are several limitations of our setup, which could be fruitful grounds for future work. For example, our interaction model did not integrate physics simulations. Specifically, our blocks were allowed to intersect and didn't interact with gravity. So the movement of blocks was not consistent with the real world. Our study also focused on interacting with objects in a range of sizes likely to be handled in reality. A future study could observe if results for our conditions, especially the hand sizes, differ when the same puzzles are scaled at much smaller or larger sizes. Our avatar hand shape and motion were both retargeted from a more faithful representation of the user's hand. For example, the avatar fingers were aligned in a straight line across the palm with even spacing between them, and the palm itself was rigid. A more realistic hand could influence our observations. Finally, future work could investigate further ways to combine efficiency with realism. Haptic feedback could be added to gloves, or grasp detection could be improved by examining user intent. Thank you very much. I'm open for questions now.
We have time for a few questions.
Hello, I'm Kojiro from Osaka Institute of Technology. I wonder whether the participants' familiarity with the devices would have affected your result. So, for example, people must have used Oculus controller or that kind of controllers before, but they wouldn't have used the glove controllers previously. So if you give more practice of gloves before you start experiments, that might have affected your experiments. What do you think?
Based on what I saw the participants do, I personally don't think so, because they actually seemed more comfortable with the gloves. The gloves themselves were it was simply motion capture gloves with markers on them, and they interacted by picking up like that and dropping like that. So they almost didn't need any instruction when I said for them to interact with the environment.
Okay, thank you.
Hello. Thank you very much for your presentation. Did you calculate or monitor how many times the participant attempted to grab? So they tried to pick something up, but they failed to do so.
We were unable to do that, but we think that it was accurate enough to record the number of grabs and drops that they did do, because the misplacing was also a good indicator of if they weren't controlling the hand very well.
Okay, thank you.